Have you ever pondered about the future of medicine? What if, in the near future, we could print human organs? It might sound like a concept straight out of a science fiction novel, but hold on to your seats because we're about to dive into a world where fiction blurs into reality. Imagine a world where the long, agonizing wait for organ transplants could be a thing of the past. Picture a future where the shortage of donor organs is no longer a life-threatening issue. This isn't just wild conjecture or wishful thinking. We're talking about a revolutionary technology that's currently in development, a technology that could potentially change the face of medicine as we know it. It's a technology that uses living cells as construction material, printing human tissues and organs in 3 dimensions. Sounds unbelievable, right? Well, the future is closer than you might think. The concept of 3D bioprinting, a technology that allows us to print human tissues and organs in 3 dimensions using living cells as construction material, is no longer a science fiction. Indeed, the journey to this technological marvel began with a simple yet audacious idea. Our story starts in the early 2000s, when a group of forward-thinking scientists dared to envision a future where we could engineer life-saving organs in a lab. The concept was simple in theory, but complex in practice. How could one possibly manipulate living cells to form a functional organ? The answer lay in a revolutionary technology, 3-dimensional printing. Originally used for creating plastic prototypes, the scientists saw potential in this technology for something far more profound. The early days of 3D bioprinting were fraught with challenges. The first hurdle was to create a bio-ink, a substance composed of living cells that could be used as the ink in the 3D printer. Early attempts were unsuccessful, as the cells would often die during the printing process. But the scientists were undeterred. They knew that the potential benefits of this technology were too great to ignore. They persevered, experimenting with different cell types, different bio-inks, and different printing techniques. After years of relentless research and experimentation, they finally had a breakthrough. They developed a bio-ink that could survive the printing process and maintain its cellular functions. This was the moment when 3D bioprinting shifted from a theoretical concept to a practical reality. But creating the bio-ink was only half the battle. The next challenge was to print these cells in a way that they could form functional tissues and organs. This required precise control over the placement of each cell and a deep understanding of how cells interact with each other. Despite these challenges, the scientists persisted. Through trial and error, they developed techniques to print cells layer by layer, gradually building up complex structures that resembled real human tissues. This marked the beginning of a new era in the field of medicine, the era of 3D bioprinting. As with any technology, 3D bioprinting has evolved over the years. Let's take a walk down memory lane. The concept of 3D bioprinting was brought to life in the early 21st century. In the beginning, the technology was rudimentary, limited to simpler structures like skin grafts. It was a time of trial and error, a time of learning. But even then, the potential of 3D bioprinting was clear as day. As the years rolled on, the technology became more refined. Scientists and engineers began to understand more about how to manipulate living cells, how to structure them in a way that mimicked natural tissue. This knowledge led to the creation of more complex structures, like blood vessels and cardiac tissues. Each success was a stepping stone towards the ultimate goal, the creation of fully functioning organs. But it wasn't just the structures that evolved. The printers themselves underwent a transformation. They became more precise, more reliable. They were able to handle a wider range of materials, from different types of cells to various biocompatible materials. The printers also became faster, able to produce tissues and organs in a fraction of the time. Yet, the evolution of 3D bioprinting wasn't solely about the technology. It was also about accessibility. In the early days, 3D bioprinters were expensive and complex, out of reach for many. But as the technology improved, so did its availability. Today, 3D bioprinters are more affordable and user-friendly, making the technology accessible to a wider range of researchers and institutions. The journey of 3D bioprinting is a testament to human ingenuity and perseverance. From humble beginnings, it has grown into a technology that has the potential to revolutionize medicine. It's a technology that could one day allow us to print fully functioning organs, saving countless lives in the process. Today, 3D bioprinting is more accurate, efficient, and accessible than ever before. Currently, 3D bioprinting is revolutionizing the medical field. It's not just a concept in a sci-fi movie anymore. We're living in an era where the impossible is becoming possible, where science fiction is turning into science fact. Imagine a world where the deficit of organ donors is no longer a crisis. A world where patients don't have to wait on a seemingly never-ending list for a life-saving organ. 3D bioprinting is making this world a reality. Today, this advanced technology is being used in various medical procedures and research. One of the most exciting applications of 3D bioprinting is in the area of regenerative medicine. This involves creating biological substitutes that can repair, replace, or improve the function of damaged tissues or organs. Researchers are using 3D bioprinting to create skin grafts for burn victims, cartilage and bone for joint replacements, and even complex organs like hearts and livers. In the field of pharmaceutical research, 3D bioprinting is also making waves. Scientists are able to print miniature versions of human organs, known as organoids. These organoids can be used to test new drugs more efficiently and accurately. This not only speeds up the drug discovery process, but also reduces the need for animal testing. Moreover, 3D bioprinting is being used in medical education and training. Instead of practicing on cadavers or mannequins, medical students can now practice on 3D printed organs. This allows them to gain hands-on experience in a more realistic and ethical way. But it's not all about the big stuff. 3D bioprinting is also being used on a smaller scale. For instance, researchers are using this technology to print cells directly onto wound sites, helping to accelerate the healing process. These are just a few examples of how 3D bioprinting is being applied in the medical field today. The potential applications of this technology are vast, and its implications are profound. Indeed, 3D bioprinting is reshaping the landscape of medicine. It's not just changing the way we treat diseases and injuries, it's changing the way we think about the possibilities of medical science. The future of 3D bioprinting holds immense promise. In the years ahead, we're likely to see leaps forward that may seem like science fiction today. As this technology evolves, we're not just talking about printing simple tissues, we're talking about the potential to print complex organs. Yes, you heard that right, we could be on the brink of printing human organs. Imagine a world where organ transplants no longer depend on donors. A world where the agonizing wait for a matching organ is no more. That's the kind of world 3D bioprinting could create. It's a world where organ failure could be addressed with a custom-built solution, printed layer by layer from a patient's own cells. This could eliminate the risk of organ rejection, a major hurdle in today's transplantations. And it's not just about printing organs. Think about the potential in drug testing. Instead of testing on animals or humans, pharmaceutical companies could test new drugs on bioprinted human tissues. This could make drug development faster, safer, and more effective. Then there's the potential in personalized medicine. With 3D bioprinting, doctors could tailor treatments to the individual patient. This could improve outcomes and reduce health disparities. But of course, these are ambitious goals. There are still many challenges to overcome. We need to figure out how to print more complex tissues, how to ensure printed organs function properly, and how to scale up the technology. Even so, the future of 3D bioprinting is bright. Researchers around the world are making strides every day. And with every breakthrough, we're getting closer to a world where 3D bioprinting could revolutionize healthcare. As we stand on the cusp of this new era, we can only imagine what remarkable breakthroughs await. To recap, 3D bioprinting, once a concept of science fiction, is now a reality. It's a revolutionary technology that has evolved impressively, from its inception as a mere idea to a tool that's changing the landscape of medicine. We've seen how it started, a novel concept, transforming into an instrument that is now capable of constructing human tissues and organs using living cells. Today, this technology is no longer limited to labs and research institutes. It's making waves in the medical field, offering potential solutions to organ shortage and reducing the need for organ donors. It's a brave new world where printing a new heart or a kidney is not just a dream. Looking ahead, the future of 3D bioprinting holds immense promise. With continuous advancements, we can expect to see more complex and functional organs printed, potentially saving countless lives. Indeed, the future of medicine is exciting and 3D bioprinting is leading the way.